Boom, boom, boom. Earth is now supercharged after being hit by a back-to-back-to-back sequence of extreme energetic events. We had a long duration G3 geomagnetic storm, immediately followed by an S3 proton radiation storm, the strongest in many, many years. And that was immediately followed by a G4 plus G5 minus geomagnetic storm, so powerful that aurora were seen down to low latitude areas like Mexico. And so now, after all this energetic loading from the sun, Earth is supercharged. She has a bunch of energy in her radiation belts, and all that energy eventually does enter into the global electric circuit, into deeper geophysical layers of our planet. Hi everyone, and welcome back to the channel. If you're new here, I'm your host, Stefan Burns. On this channel, we cover space weather, earth geophysics, geologic events, metaphysics, so much more. So if you like the sound of that, then please subscribe. In today's video, we're going to be covering how all these things here are connected, because we have the sun undergoing its own magnetic flip right now. We are in solar cycle 25 maximum. This creates strong solar storms. This interacts with our magnetic field, altering our plasmasphere, and then that energy from our plasmasphere eventually reaches our global electric circuit and interacts and creates things like Schumann resonances and lightning. So today we are going to talk all about the radiation belts and how now, after this double sequence of geomagnetic storms, also with that severe proton radiation storm, how there is new flux being added to the radiation belts and new structures are forming, and that may take a few weeks to play out. We'll talk about the great G5 storm that we had back in May for context, so we can see just how radical some of these changes can be after very powerful geomagnetic storms, and then we'll talk a little bit about what's coming ahead. Before we start, I would like to extend my heartfelt appreciation and thanks to everyone who wished me well over the past few days, because I have been sick. That is why I have not released some videos recently. I'm still kind of congested, and I know that all your prayers definitely made me recover faster, because this has happened before with the channel. It's really quite amazing. The miracle of prayer, all the healing energy. Thank you. And so it makes me wonder how bad this would have been if I didn't have your healing prayer. So again, thank you so much. Happy to be back reporting for you today. Here we have this G3 geomagnetic storm and G4 plus G5 minus storm sequence. And so we see that this is a long duration G3 storm. We only hit G3 for a single KP 3-hour index there, but overall we had a lot of values there in the G2 range. And so this was a long duration storm, and the DST index got quite low on this, surprisingly, because of how long duration it was. Then on the 8th of October, right around here, 8th, 9th of October, we had that S3 proton radiation storm start from that solar flare, which then triggered this really massive geomagnetic storm. And so as the storm was cooling off, we were getting completely bombarded with solar protons across all the different mega electron volt levels. And then we had this storm. And so there's that triple sequence. And what happens after you get energy loading events like this, whether it's a geomagnetic storm or proton radiation events, things of this nature, is you get changes to Earth's plasmasphere, and it becomes extra charged because you have all this solar energy and mass coming in from interplanetary space. And so whereas before Earth had its plasmasphere and its, you could say, energy budget, now it's just like being forced and loaded and loaded and loaded with more and more and more. And so Earth will hold on to a lot of that energy, and a lot of it actually gets precipitated down into deeper geophysical layers like the ionosphere, like the lower atmosphere, and like the lithosphere, the crust of the Earth, and even deeper into the mantle and beyond. And so that is what's happening right now. And we'll look at data from that great G5 geomagnetic storm back in May so we can better understand some of the changes that are unfolding right now on this planet. Here we have our electron radiation flux going from L1 all the way to L8. And L1 would be 1 Earth radii away from the center of the planet. L8 would be 8 Earth radii away from the center. We'll talk more about that in a future slide so you can understand it. But what I really want you to see here are the two peaks that we have in electron flux. This is the inner radiation belt there, This is the outer radiation belt. We see our flux rating there. This is 10 to the 3, 10 to the 4, 10 to the 5. This is 0.5 to 0.6 mega electron volt electrons, and they are hitting a square centimeter every single second. And so we see that there's about 5,000 or so in this inner radiation belt hitting that sample size area every second. And then here in the outer radiation belt, there's quite a bit more. That's where most of the electrons live in the radiation belts, is in the outer radiation belt. It is electron dominant. The inner belt is proton dominant. And you see that really is highest in its flux at around 4 to 5 in the L shell. We'll also notice here this gap at around 2.5 to 3. This is the L slot, and this is where there is a depletion of electrons and other ions, and they rain down and precipitate to our planet due to different geophysical processes, which we'll touch on later, like lightning strikes and Schumann resonances. So what I want you to watch here, though, is the progression as we go from May 1st of this year all the way to the end of June, because we'll see some pretty dramatic changes in the radiation belts for this spectra of electrons because of that great G5 geomagnetic storm. At the beginning, pay special attention here to this L slot. So I'm going to hit play, probably hit play and stop a few times. There we go. Everything's normal. Then that storm hits. And immediately you'll notice that all these electrons, they get pushed down into that L bracket basically at the beginning and early part of this geomagnetic storm and the few days following afterwards. And so we have most of these electrons here in the outer radiation belt. There is a big push of those electrons. The outer radiation belt gets effectively kind of destroyed. It's like a degradation event, and they all get pushed into that L slot. And so now you have a whole bunch of them being fed into the Earth. That is the stage that we are at right now with this post-recovery phase from that G4 plus, G5 minus storm that we just came out of. But if we watch this continue, it gets very interesting, because what we'll see is that it actually forms a 4-shell structure, which, according to the authors of this paper, has never been seen before. And so we'll notice that things start to change. It starts to get pushed in. We go higher in our date here as the colors increase. We see it show up really nicely starting about now. There's our first one, second, third, and fourth shell. And so after that great G5 storm, multiple radiation belts existed, whereas normally there are just 2. And you'll notice the date on this is June 30th. And so that storm was quite exceptional. And so it takes a long time for these things to evolve and unfold after a significant geomagnetic storm like that. The one we just came out of is not as strong, but it is a very powerful storm that we just came through. So I don't expect this to be exactly the same, but we do have similar dynamics unfolding right now. And so we have this big surplus of energy and charge in that L slot region precipitating down to the Earth right now. And then over the next few weeks, I would expect us to take on a very unique radiation belt structure. And there's connections between radiation belts and earthquakes, and I've talked about that before on the channel. We're not going to go into it in this video, but we see here with this great G5 storm how we form this very unique 4 radiation belt structure, and it was really appearing nearly 6 weeks after that storm came to a close. And what are radiation belts? Well, radiation belts have been observed for the planets in our solar system with strong magnetic fields like Earth, Jupiter, and Saturn. Existing within a magnetosphere, they form a toroidal shape and are filled with highly energetic particles like protons, electrons, and heavier ions such as helium. They are dynamic structures which change shape over time depending on internal and external influences. They are also known as the Van Allen belt. So again, with our animation here, we're seeing a typical 2-belt structure. What I want you to notice here is that this outer belt is more focused around the high latitude regions of our planet, where the closer inner belt is much more focused on those mid-latitude zones in terms of where the magnetic field lines are connecting. We'll talk about those conjugate points in a future slide. But right now, after this storm, we are going to be having multiple radiation belts form, not just the typical 2-part structure, and they're going to be lasting for probably at least a few weeks, if not even like a month or longer. And so this is going to be changing our energetic dynamics going out all the way into November. And so we have a tremendous amount of solar activity right now. And so that could then further influence what's happening on our planet energetically. Because when you have these unusual ring radiation belt structures, and then you get, let's say, another powerful solar storm to come in, some of these sunspots are still there. They're rotating through the far side now. They'll appear back on the Earth-facing side of the sun. If they survive, it's likely that they will, then things could really get bizarre and unusual as it relates to the energetic structures that are in our near-Earth environment, our plazosphere. And this has connection to our global electric circuit. This has connection, therefore, to our weather, to earthquakes, and so much more. Here is a pretty simple graphic that shows some of the things that occur when our magnetosphere is crunched by space weather, like strong solar wind changes or solar storm impacts, solar filament impacts, etc. And so what happens is that you have all this new solar mass and energy coming into our planet, really pushing in deeply, and this can all cause ion precipitation. And so here is our outer radiation belt, here's our inner one. We see that based on wave-particle interactions, you can have these ions get pushed deeper into the loss cone. This is that L bracket that I'm talking about, and then that precipitates into the atmosphere. We see that right there. So we have solar protons in green, we have auroral electrons there in yellow, we have MEE electrons there in burgundy, and they all come in and they cause this energization of the planet. This then influences the global electric circuit, influences things like Schumann resonances, telluric currents, and we are connected to the global electric circuit bioelectrically. And so if you'd like to learn more about how space weather affects our bioelectricity, I have a link in the video description. Give that 75-minute video a watch after this one. And here's some data showing what's happening right now in our radiation belts, at least at 5.6 Earth radii, which is geosynchronous orbit, as it relates to electron flux, and specifically from 0.86 to 1 mega electron volt. And so you'll see that everything was normal. We were having normal electron flux. We have these rises and these falls due to solar radiation, right? Earth is rotating into view of the sun. Sunlight causes energization of the plazosphere, speeds things up. But then we had this G3 storm right there. We see that very nicely. That causes a drop in these electrons from these higher L shell brackets. 5.6 Earth radii is pretty far out there in the outer radiation belt. So that's why you get all those to drop. Then you do get this enhancement in the outer radiation belt. Then we see this another drop there. That's from the most recent G4 plus G5 minus storm. And now we see our electron flux in the outer radiation belt, at least at geosynchronous orbit, is much elevated as compared to before, by about an order of magnitude. And so we already have in our outer electron belt a lot more of these 0.86 to 1 mega electron volt electrons. That is a pretty energetic electron. You can measure these in the kilo electron volt range. They can also go higher, but the fact that we bumped up an order of magnitude from this sequence of G3 storm, S3 proton radiation storm, and then G4 storm is quite remarkable. And that energy is going to be in our sphere now for quite a while. It takes some time for this to dissipate. And here is that graphic that I promised you, showing the near-Earth energetic environment with all the different L shells, our outer radiation belt, our inner radiation belt, the ring current, Earth, the ionosphere. And so we'll start with our Earth. Going from the core right there to the surface is L1. And then you go up another 1,000 kilometers, you get to the edge of the ionosphere, which is pretty close into the planet, you could say. Then L2 is now 1 extra Earth radii added on top of going from the surface outward. Then you have L3. You can go all the way out to like L10, L11. That's where the outer radiation belt starts to fade out. Again, most of the flux in the outer radiation belt is trapped in this L4 to L5 range under normal situations. This is like quiet conditions and there hasn't been a storm for a while. You also will notice this ring current here that extends all the way out pretty far. This is made up of electrons, protons, also heavier ions. Like during a geomagnetic storm, oxygen ions come up from the atmosphere and enhance the ring current. And then eventually they'll go back down to the ionosphere as they decharge. And then you'll see this inner radiation belt there, which is proton dominant. There is that L slot. And so the L shell is just really an easy way to describe the magnetic field lines at a certain distance away from Earth. expressed in terms of Earth radii. They also allow us to understand conjugate points on the planet because the magnetic field, as you can see here, goes out like this. See that field line? And then curves back around and then goes into a different part. So there are these natural energetic connections between the northern hemisphere and the southern hemisphere. And as you get closer to the equator, they get closer together. And so the high polar regions are connected together, and then the mid-latitude regions are connected together on each side of the equator, and so on and so forth. Earth's magnetic field, of course, goes from the core to infinity. The radiation belts go from about 1.5 to 3 Earth radii, and then 3 to 10, and then the ring current goes from about 1.5 to 9.5 Earth radii. Here's some more data showing exactly what is happening on our planet right now. This is our electron flux map for the globe, going from 0.5 to 0.6 mega electron volts. This is from September 30th to October 6th. You'll notice here the South Atlantic anomaly, and you'll see the level of flux here with this legend. So you'll see that orange is pretty high up there, right? And then as you get darker in color into the blues, the flux gets lower and lower. But let's just go over to our week right now so you can quickly see the change. That is where we are over the past week. And so this encompasses that G3 storm, the S3 proton radiation storm, and then also that G4, G5 storm. You see a really strong enhancement there, another one there, and then the South Atlantic anomaly also got greatly enhanced with electrons at this flux level of 0.5 to 0.6 mega electron volts. So this is really quite significant, and how these radiation belts are going to morph and change over the next few weeks, it's hard to forecast, but we can better understand by looking at what happened with that great G5 geomagnetic storm. And here is our KP index for that great G5 geomagnetic storm back in May, starting to be called the Mother's Day superstorm because it was so strong and it occurred on Mother's Day. We see that we had 30 hours where the KP index was greater than or equal to 8. So a very long time duration. The KP index is measuring swings in Earth's magnetic field strength at the surface. The stronger the swings, the higher it goes. And so 8 is very close to 9, and we actually had 9 hours in total where the KP index was right up there at 9. It does not go higher with the KP index, but some of these values actually spiked over 10, 11, 12 using higher time resolution views. We also noticed a second pulse of activity there, but this was one of the strongest storms in decades, and so it caused really significant changes to Earth's plasmasphere as a result. And here is some data showing just how remarkable that Mother's Day superstorm truly was. We have our proton flux in the radiation belt going from pretty close to the surface all the way to about L8. And this is for May to June 2024. And so we see May over here and then progresses over to June. You'll notice our Mother's Day superstorm there. You'll also notice this other solar energetic particle event there, smaller in scale. We're not going to discuss this, but it is useful for context. But what you'll notice here, across these different mega electron volt ratings, the further down you go, the stronger the protons, because this here is 92 to 126 mega electron volts up top. It's only 9.5 to 13. You see that during that great G5 storm, the entire radiation belts, from basically this, like the inner belt going close to the surface all the way out to about L8 and perhaps even beyond, because this gets cut off, got super energized with these protons. So effectively, just the sun sent off a bunch of mass, right? It launched off a whole bunch of its own mass into interplanetary space, and then Earth caught that like a catcher in a mitt, caught the baseball, comes right in, and you see that it actually is able to go really deep into our radiation belts. Here is the inner radiation belt. You see how that's normally charged even during these quiet times, right? And then we see, though, during this G5 storm, how it just pushes all the way down into actually cross what some researchers called an impenetrable barrier, which is that L2.5 slot, where normally a very fast ion precipitation due to the effects of lightning and ion cyclotron resonance and ELF waves. We'll talk about that a little bit more later, but you'll see across these different energetic spectra for these protons that they were able to push super deep into Earth's radiation belt. It actually was a pretty long duration event, as you can see there, a little bit of a tail on all these with these little speckled dots there, but really, really significant because you don't see this every day. And in fact, this is the strongest storm that we've had in effectively 20 years. And so we're still in many ways processing and integrating that energy. Some of it gets sent out the magnetotail, it gets flung out of these plasmoids, or some of it just kind of dissipates out around the magnetosphere. But in general, once the Earth captures onto solar mass and energy, she holds on to it and has to work it somehow into her system. And so generally, eventually, it'll enter down into the deeper layers. And so we're not floating around in space unless you're on the International Space Station, and that's not a good place to be when this happens. But that doesn't mean that we're not interacting with these energies. Earth's magnetic field protects us to a great degree, but again, 6 weeks later, this was starting to change and filter down still after that storm. And so there can be very long duration effects associated with these really powerful geomagnetic storms like this G5 one here back in May, like the one we just got out of. That is why I'm making this video. And it's not only just in terms of like biologic effects, we're bioelectric beings. It's not only in terms of like spiritual and consciousness effects, it's also in terms of geophysical effects like changes to our weather, the global electric circuit, perhaps changes to earthquakes. There is evidence that changing radiation belts influences earthquake dynamics and can trigger really powerful earthquakes with like a time delay after really big storms. And here we can see that graphic showing the changing radiation belts after that G5 storm once more, but this time we have different spectra for the electrons. And so we have the 0.5 to 0.6 mega electron volt ones there. This is the same graphic, but now all of them are layered together. Here we have 1 to 2.4 mega electron volts. There were 3 other channels in between, channel 2, 3, and 4. They were all very, very similar. You can see that these have the same 4 belt structure. So they emitted them from the research paper in terms of presentation. But then we see channel 6 here, 2.4 to 8 mega electron volt protons. It is different than these other 2. So the great Mother's Day geomagnetic storm of 2024 was so intense that it led to complete depletion of electrons in the outer radiation belt. The slot region at L2.5 was completely filled, and energetic electrons even penetrated into the inner belt less than L2.5. Eventually, perturbations caused by the May 11th superstorm led to the formation of 4 distinct subbelts for electrons with energies less than 2.4 mega electron volts, and electrons 2.4 to 8 mega electron volts also underwent dramatic reorganization. So we see that 4-belt structure once more. 1, 2, 3, 4. Same deal here with the softer spectra. 1, 2, 3, 4. And then as it relates to our more energetic electrons, these are very, very energetic because again, an electron has 1,800 times less mass than a proton. So for it to reach a mega electron volt is very significant. It has to be traveling very close to the speed of light to do so. We see in general just a 2-part structure here. So there is this inner belt there at about 1.5 or so, and then we have this L slot at 2, whereas normally it's 2.5, and then we see it come down here with this big increase in flux there. Again, this is like late June at that traditional L slot range, and it still is the L slot. And so what does that mean? What does it mean that there is an L slot, this region where ions typically don't exist? Let's explore that. Here's an animation showing the creation of the L slot. Notice that lightning there. Ultra low frequency electromagnetic waves generated from atmospheric electrical discharges, like lightning, travel away from Earth following magnetic field lines outwards to the radiation belt, stimulating electron flux earthwards, greatly reducing the density and intensity at the L2.5 region, creating what's known as the L slot. And so there is a magnetic field line at that L2.5 zone that connects the northern and southern hemisphere. And the reason why it's specifically at that range is because of the electromagnetic waves that are generated by lightning strikes. They generate frequencies across the entire light spectrum. They've even measured gamma rays off of lightning strikes. But the ones that survive, that don't attenuate out that quickly, are these Schumann resonances at about 8 hertz, 14 hertz, 20 hertz, so on and so forth. They go up to like 45 plus hertz. And so those specifically like to kind of congregate and move along that L2.5 magnetic field line. Of course, these are invisible lines, but due to resonance mechanisms, they will travel specifically along that magnetic field line like this And then when they interact with these particles there, which are trapped in these regions, they then cause this particle wave interaction. They cause them to destabilize, and now you have this precipitation that occurs, giving you the normal 2-slot region. But as we saw with that great G5 storm, we had 4 of those radiation belts, which means that there is a slot in between all of them. And so there was new particle flux coming down in different areas than normal after that G5 storm, and that is what's occurring right now and will continue to occur through the rest of October into November, very likely from this storm that we just came out of, because it was so powerful. And so new parts of the planet, not this typical 2.5 magnetic conjugate spot, but new parts of the planet are going to be receiving extra energy from the radiation belts as a result, because it is a natural resonant feature of the Earth due to lightning strikes and the electromagnetic waves that they produce, the ones that are naturally resonant with the Earth, which are the Schumann resonances. And so when you get this big push of energy from the outer radiation belts into the inner radiation belts and you fill up that L slot, all of a sudden now you're having a ton of energy come in and flow down in addition to those other zones, that 2.5 region. So in general, there is a massive amount of particle precipitation that occurs after a geomagnetic storm, and the more severe the storm is, the more severe the particle precipitation is and the longer duration it will last. Here we have a graphic that really nicely shows those magnetic conjugate points, and there are a whole bunch of interesting phenomena that are associated with them. And so during powerful geomagnetic storms, Earth's magnetosphere is loaded with this solar plasma and these fresh ions, which are new to the planet. They create these new radiation belts in the near-Earth environment and remain stored there for significant lengths of time like we saw. Now, Earth's magnetic field extends outwards into space, and these field lines connect the northern and southern hemispheres together through magnetically conjugate points. We see that there. So we see this field line, and we see these magnetically conjugate points. And so the L shell position determines the location of the magnetic pairs. The lower the L shell, the closer into the surface you are, the closer these points are connected together. There's less travel, but as you go higher and higher, then you have these greater and greater magnetic conjugate points. And so as all that energy gets pushed in to the more inner radiation belt and creates these other radiation belts, you have more energy flux in these mid-latitude, low-latitude, and equatorial regions than normal. And so that's really, really interesting to me, because during a geomagnetic storm, you have all these ions coming in, flowing down the polar field cusp. And you see these really big magnetic swings, really centered in the Arctic circles here and there. We get them around the globe, but they're less severe than in these very high latitude regions. But after the storm, you have all this solar mass and energy now more stored in these mid-latitude zones, raining down in on them. And so if you live in one of those mid-latitude zones or low-latitude zones, perhaps you don't really, let's say, feel those magnetic field changes that occur during the geomagnetic storm itself if you're bioelectrically sensitive. But then afterwards, there can be a very long time delay with this. And this also, again, relates to the global electric circuit, weather patterns, earthquakes. And so then you can have enhanced earthquake activity. At least the preliminary evidence suggests this. This is a hypothesis. You can have enhanced earthquake activity along those new L shells where those radiation belts are created. Typically get a 3-ring structure, but as we saw with the great G5 storm, we had a 4-belt structure that formed. And what really made this recent sequence of events really, really wild is the fact that we also had Hurricane Milton at play as that geomagnetic storm was occurring. And so Hurricane Milton made landfall at Category 3, which is very powerful, but it was kind of anomalous in the fact that it had so much lightning activity. We see that there. Look at some of these flashes. This is data by NOAA, and it's just absolutely wild how much electrical activity was occurring in the atmosphere at this time. So why do I mention this? Well, because again, lightning strikes are producing those ultra low frequency electromagnetic waves, which then travel along those magnetic field lines, those L shell pairs, and pull that energy in. And so we were having this big push of energy come in from the sun. It degraded the outer radiation belt, pushed everything down, and loaded the inner radiation belt with even more energy and mass from the sun. And then as that was occurring, Milton is creating all this energy, lightning strikes, and these electromagnetic waves to then cause rapid precipitation of that. And so This hurricane now has expired. Of course, there were other storms on the planet too, though this was very likely the most severe. But we just had this very rapid transfer of solar mass and energy as a result of that sequence. And so we had that G3 storm, the S3 proton radiation storm, this G4, G5 storm, and then a lot of energy that we pulled in from the planet immediately got pulled down into some of the lower Earth systems. And so now that is going to be interacting with our planet and altering things. For example, when you have rock circuits that are at very critical stress thresholds, and then you add a very strong telluric current through it, that can then cause those molecular bonds that are holding everything together, resisting that tectonic stress, to then finally slip, and then you get that earthquake to occur. There's a lot of electrodynamics at play with earthquakes. And so we have just in general a lot of energy now in our planet. Earth is really, I'm not exaggerating, she is supercharged at this moment in time, and that's going to stay that way for about probably at least the next 2-3 weeks, if not longer. I have some more recent data to show you to really drive that home. Here we have our neutron flux. And so what we are measuring with neutron flux is effectively the balance between cosmic rays and solar energy. Because when you have more solar energy coming in, you have those magnetic fields stronger as a result, and you are pushing out more cosmic energy, these cosmic rays, these very high energy particles from interstellar space and beyond. And so during solar minimum, you have very high cosmic rays. This is counted with neutrons because they create neutrons in the upper atmosphere. And then during solar maximum, you get a decrease in cosmic rays, a decrease in these neutron counts. And so we see that occur with geomagnetic storms. Here is our G3 storm. That is a pretty significant Forbush decrease. And then we see that G4, G5 storm that we just came out of really drop our neutrons there, effectively pushing out all these cosmic rays because the solar energies are so strong. We see that our scale rating there, and we actually see that drop right there on our data going back to 1965. Now it has started to recover, so it doesn't show that there, but we have this G5 storm from May somewhere right in this zone, but it did not cause as significant of a neutron drop as this one did because of this unique, triple sequence of events that occurred with that G3 storm, the S3 proton radiation storm, and then the geomagnetic storm that we just got out of. And so this was a significant event. Its dynamics will be different than that G5 storm, but in many ways, it's a little bit more severe in some measures. If we're looking, for example, at its ability to push out these cosmic ray sources from our energetic system, it was much stronger than that G5 storm that we had in May. Though the Forbush decrease may have been less, the combination of that G3 storm with the G5 was really quite significant. And that's really the theme in general for 2024, because we have seen a sequence of really powerful solar storms happen this year, and as a result, very powerful geomagnetic storms altering our global geophysical energy balance. And so we see here May, this G5 plus storm, the DST index went down to negative 412 nanotesla. This is a measure of the ring current. The stronger it gets, the greater this drops. What you'll notice about this great superstorm is that it took a very long time for the DST index to climb back up to about 0, for the ring current to finally subside back down to normal. And we see our most recent storm here. So in terms of DST index, not as severe, though it's more similar to this one than it is these other storms that we see here. But look at our sequence here in October. We see that G3 storm, the DST reached a lower value of negative 153 nanotesla, and then the lowest value reached for this G5 minus storm was negative 335 nanotesla, so quite significant. Then we also had quite some powerful storms in August and September. We had a G3 minus storm here. DST went down to negative 101 nanotesla, followed by a G4 storm, negative 188 nanotesla. Then in September, there was a G3 storm, negative 114 nanotesla, a G4 minus storm there, followed right afterwards, negative 116 nanotesla. The reason why some of these aren't as severe as you may expect is because the duration of the storm matters. And so some of these are short duration, but they had very high electromagnetic kind of pulse impacts on the planet. But this is a really big sequence there. That is a really powerful geomagnetic storm there. If we look at some of our historical data, we'll put this into context because we'll see that this rapid sequence of storms that I show here is pretty anomalous if you look at more quiet periods of solar activity, or in general, like solar cycle 24, our last solar cycle. Here we have data showing 0.5 to 0.6 mega electron volt electron flux in the radiation belts going from May 2013 all the way to the end of 2017, and our y-axis there is L1 going to L8. And so you see that electrons in this spectra, they like to hang out in this outer radiation belt. You see a very slight enhancement there in the inner radiation belt. You don't really notice any significant structures that develop for a long duration of time during this time frame, which encompasses solar cycle 24, the descending phase of solar cycle 24. And down here we have our DST index. And so let's just go right to it. There on our y-axis, we have negative 200 nanotesla, and then we have a couple clicks below that, so it goes down to about negative 220 nanotesla. You see a few of these storms there that we had went down to about negative 200, negative 220, like these two right there went to negative 200 nanotesla. And then we had some other storms there, but during this entire time frame, which is like nearly 4 years, right? We didn't have any storms that went greater than negative 250 nanotesla. And just this year, we had the G5 superstorm in May, negative 412 nanotesla. And then our most recent one, just a few days ago, negative 335 nanotesla, with the whole bunch of other geomagnetic storms that I showed you just in the past couple months that went to pretty low values. One of them was negative 188, a whole bunch in the mid 100 range. And so we see, those are in there as well. What we've had just in the past few months eclipses anything that we saw during this like 4-year-long period. And so the Earth is no stranger to really powerful solar storm impacts. They do occur. We have records of them going back all the way to the Carrington event. Even further back, if we look at radiocarbon measured via tree rings like 775 Common Era. These are known as Miyake events. We have a whole bunch of storms that occurred in the early 19th century, a bunch back in like 1957 during that solar cycle, which is the strongest of this solar maxima period, this grand maxima that we're in. But this is still very, very bizarre and anomalous as to what's occurred in other time frames. So it's important to put that into context because there's just a tremendous amount of energy coming into our planet at this time. Again, the Earth has seen these sort of events before, but it's been a while. And so you may not be used to that biologically, right? It takes time to adapt to these changes, and the Earth may not be used to that geophysically. And so we don't know how those energies eventually are going to be formatted on our planet and how some of that energy then may be re-released. This is a developing story. I will keep you up to date as to what is happening on our planet energetically. I'll keep track of the radiation belts and the flux levels of them. I just found a new data portal, which is like absolutely mind-blowing. It's a fantasy for me because there's so many different data modules for me to look at. And so I have a whole bunch of new animations and goodies coming your way over the next few months. If you'd like to see that, then please subscribe, like the video, help this channel grow. Thank you all so much for helping this channel grow already. And for all the new subscribers that are here, that is awesome. We just recently hit 100K. Now we're at like 117. So really things are growing so fast. It just shows that so many people have an inherent interest and curiosity and love for understanding our Earth, what she's going through, and what's occurring in general with our solar system. So if you'd like to say praise again, I'm your space weatherman, Stefan Burns. Feeling better. I'll be back very, very soon. Until then, I wish you a great day.